So today we're going to talk about triangle similarity. We are on section, probably 2 of the chapter. Going to be a little bit lengthier today than normal. We've got a lot of things we have to talk about with triangle similarity. So just kind of prepare yourselves for that a little bit. Today we'll do day 1, tomorrow day 2. Mostly today we'll take care of everything, kind of leave us in front today. We'll get most of the notes taken care of today, give you about the last 15 minutes to kind of work on it, and then you have most of tomorrow. We'll do some more examples tomorrow, but vast majority of tomorrow will be a work day. And then we got 3 days of geometric means. So just really 2 topics to cover this week, but these topics are a little bit more difficult and a little bit confusing as far as things go. So triangle similarity. There are 3 things we're going to look at with triangle similarity today, and we're going to do examples of them. We're going to talk about angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So there's 3 different similarity statements that we're going to talk about today. And then we're going to go over examples to make sure that you can identify which one of the 3 is being used and how we go about writing statements with them. So we're going to start out with angle-angle similarity for your notes. Angle-angle and an angle-angle is not one you've heard, but you've heard side-side-side, you've heard side-angle-side, you've heard angle, maybe angle-angle-angle, and side-side angle, and all those different things. When we talked about congruency. Now we're talking about similarity. And the difference between similarity and congruency is when we say things are congruent means the same size and same shape. Okay, so they look exactly the same. When we're talking about similarity, we're saying that they look similar, but they're not the same. Okay, so some of the angles might be congruent, or the angles might be congruent, but the sides are going to be of different lengths. So they're the same shape, but not necessarily the same size when we're talking about similarity. And the first similarity statement that we can use is what we call angle-angle similarity. And what angle-angle similarity says, it says if 2 corresponding angles are congruent, then the triangles are similar, meaning they look the same. So what we want to be able to do is we want to be able to look at an object or look at 2 triangles and see if they have 2 corresponding angles. And if they have 2 corresponding angles, we can then say that they're similar, that they're the same shape as each other. Okay? So for example, if we have these 2 triangles, go ahead and write these in your notes. We want to be able to do 2 things with these. We want to be able to identify if they're similar or not by angle-angle, because that's the only one we know. That's the first thing we want to do. And then we want to also be able to make a similarity statement. This triangle is similar to this triangle. So we've got 2 things we have to do. First, determine if they're similar. And then once we've determined that, write that similarity statement. So if we look at the 2 triangles, you notice that we've got 75 and 75. So there's one set of corresponding angles that are congruent. We've got 31 and 31. There's the second set of corresponding congruent angles. So we can say then that these are similar by angle-angle similarity. And this right here, that's the symbol mathematically that we use for similar to. Okay, so this means that these two triangles are congruent by angle-angle similarity. Now, the next thing we want to be able to do is we want to be able to write a similarity statement. In other words, triangle ABC is similar to what triangle? This is Tony. Don't see right now. Might be. I'll look around, but they're... Okay. Yep. Bye. So we got triangle ABC. is similar to triangle. So if I have angle A, now the thing with this is order matters. So I've got triangle ABC. Like we did with congruency statements, we have to put things in order of pieces that correspond with them. So the way we put the first set of triangles, it doesn't matter. I can put ABC, I can put BCA, I can put CBA, I can put whatever I want. But with the second set, it matters now. Okay? So in the first one, I put A first. A is right here. I have to match it up with the angle that's congruent to it. Okay? So angle A matches up with angle D. So those two are congruent to each other. They have to go in the same spot. Angle B is right here. Now, the only other one that doesn't have anything with it is this one over here. So B and E have to go in the same spot, and then C and F have to go in the same order. Okay. So that's my similarity statement. So like I said, the first one doesn't matter. I could go BCA. The second one does matter, though. Angle B associates with angle E. Angle C corresponds to F. I don't know why I put a C there. F and angle A and angle D. So the order matters for the second one. Questions with that one? Okay, let's look at the second one. So the only property we know right now is angle. If we look what we have a tick mark there and we have a tick mark there. Okay, so we know that angle V and angle Y are congruent to each other. Are there any other angles in there that are congruent to each other? Okay, this angle here has to be congruent to this angle here because vertical angles are congruent. So though they weren't marked, we know by previous learning that vertical angles are congruent. So I have two angles that are congruent to each other that are corresponding. So we can say that this is angle similarity. I'm going to go triangle VXW is similar to triangle. Which one corresponds to V? Y. X corresponds to itself, and then Z is the only one we have left. So this is what we're going to be looking for in our assignment today as well. Are they similar to each other? If they're similar to each other, which one is it? In this case, we only know angle, and then being able to write the similarity statement as well. Okay, so that's angle. That's the first one. Two corresponding angles of congruent, then they're similar. The next one is side similarity, SSS. So this is side similarity. In side similarity, two triangles are congruent. Two triangles are similar if their corresponding sides are proportional. If all corresponding sides are proportional, then the triangles are similar. This is why we worked on proportions, ratios and proportions on Friday. Because we want to be able to solve ratios and proportions, not only reducing them, but also cross multiplication if we have to. Okay, so side similarity says all corresponding sides are proportional. If that happens, then they're similar. So this one's pretty easy to identify if it's the one you're trying to get. If you have 3 sides from one and 3 sides from the other, then you're trying to see if the sides are proportional to each other or not. So here's our first one. We have triangle QPR and triangle TSU. We want to determine if they're similar or not, and then write the similarity statement. So because we have 3 sides in one and 3 sides in the other, we're going to try to see if side similarity works. In order for this to work, the sides have to be proportional. So we have to write ratios. So the way I write the ratios is I take the biggest one from the first triangle. The longest side from the first triangle is 5 over the longest side from the other triangle, which is 10. And then I reduce that ratio if I can. That reduces to 1/2. That has to equal. Now I go to the second longest side of the first triangle, which is 4, over the second longest side in the second triangle, which is 8. And then I reduce that. That reduces to 1/2. So it looks good so far. Then I go to the smallest side over the smallest side. And I reduce that. If all 3 of these are the same, then side similarity works. If one of them is different, you're done. It doesn't work by side similarity. All 3 of them have to be the same. Now that is done, and this almost becomes the harder part with side similarity, it's writing the statement. If I take PRQ, and we said in the last example that the order that we put the first one in doesn't matter, but now it does. So I look at the one that's P, and it has the smallest side and the middle side going to it. So I look for the one that has the smallest side and the middle side going to it. So P corresponds to S. I put R second. It has the longest and the middle. So the longest in the middle is U. And then the only one we have left is T. This similarity statement is sometimes hard to write. And I've kind of found that I just pick one to do this. And then when I point it out, it's small and middle. I look for small and middle. And where they come together, that's where I go. Now, in this one, it wasn't bad. They're all in the same spots. It's not always the case. I was doing one of the problems from tomorrow's assignment, and it took me forever to figure it out because it was just the way it was drawn. These can be hard to do, especially when they're not in the same spots. Okay, let's look at this one. So we've got triangle DCE. And we've got triangle GFH. I've got 3 sides of both of them. So we're going to try to see if side similarity works or not. So I just left to right. I look for the largest one. The largest one is 35. What's the largest on the other one? Or the longest on the other one? 28. Now I'm going to reduce that. They're both divisible by 7. So that's 5 over 4. Now I go to the middle. That's 32 over 25? Are they divisible by anything? Both of them divisible by anything that's the same? I don't think so. 25 is 5 and 1. So this is 32 25ths and this is 5 fourths. Are they the same thing? No. So since 5 fourths does not equal 32 25ths, they're not similar to each other. And they're just two random triangles that are out there. Okay? And they don't look the same. They're not the same shape. They're not similar to each other. Okay? So there's the first two. We've got angle-angle similarity, and we've got side-side-side similarity. The last one that we have to talk about is side-angle-side similarity, SAS. Side-angle-side similarity. Side-angle-side similarity says this: if two corresponding sides are proportional and the included angles congruent, then they're similar. Two corresponding sides proportional and the included angle congruent, then they're similar. Remember what that word included means in a triangle. This angle is considered to be an included angle because it's made up of these two angles that I'm looking at. That's what we mean by included. Okay, we had side angle side congruency, and what always got us was that angle had to be included. So it has to be between them. Think about it as it could close up on it with our given sides. So if we look at an example of this, again, sometimes it's pretty easy to see if we're going to try to prove this to be congruent by side angle side. You're given one angle and two sides. If you're given one angle and two sides, like you are in this example, we're going to try to attempt to see if side angle side similarity works. So we have the angle. That angle is the included angle because angle K is made up of two given sides and angle N is my two given sides. So it's the included angle. So the angle's taken care of. Now the sides have to be proportional. So it doesn't matter what order you do it. I tend to like to do largest over largest. So 20 over 15. And I reduce that. They're both divisible by 5. So that reduces to 4/3. That has to equal 15 over, why'd I put 8? Let's try this again. This has to equal 8 over 6. Okay. Make sure you don't make the mistake that I almost made there. Okay, I just all of a sudden looked for the next smallest side. My top, the top has to come from one triangle. The numerators have to come from one triangle. The denominators have to come from the other triangle. And I almost messed it up. If you're looking up, kind of said I wrote the other one. Okay? The numerators have to come from one. The denominators have to come from the other. I think this is 4/3 as well, right? So that works. So they are congruent, they are similar by side angle side. Now we have to write the similarity statement. So triangle, I always start with the congruent angles with this one. So I'm going to go KJL is similar to triangle And if I go with this congruent one, I know I have to start with n. That's why I always start with the one that's congruent for this one. Now I went to j. So j was down my shorter of the two sides. So I have to go down the shorter of my two sides. That takes me to m. And then p is the only thing I have left. These aren't too bad to do as long as you start at the one that you have congruent and follow the shorter side. That's going to go second. And then you're only at 3 letters, so then the only one that's not there has to go last. This is side angle side similarity. Okay. This is where they start again, depending on what you can see and how you see it. This is where these can start to get a little bit more confusing. So I'll give you a couple seconds to copy this one down, and then we'll go over it. Now, the biggest one with this thing is making sure you see what they're looking at. So I've got a triangle. I've got a triangle right here. Okay, so I'm just going to kind of sketch it over here. This is triangle ADE. I know this is length 15, and this says length of 12. I also have this purple triangle right here. So that purple triangle has angle A, so I know those two angles are congruent to each other because it's the same angle. It's right there. So this is angle A, triangle ABC. What's the length of AC? That's 21, right? And this is 25. So if I go 15, that's the longest side of triangle ADE. That's 15 over 25. Does that look like the right ratio? Longest over longest. 1, 2, 3/5. That has to equal shortest over shortest. So 12 over 21. I think that's 4/7. They don't equal each other, so therefore these are not similar. Okay.
I forgot my phone in here.
Your phone. Okay. So those are our 3 different ones we have. Angle-angle similarity, side-side-side similarity, and side-angle-side similarity with 2 examples of each of them. So now what we're going to do is we're going to move on and say, all right, we need to determine whether the triangles are similar. If they are similar, we're going to state how, and then we're going to write the similarity statement. Okay, so here's the first one we're going to look at, and we're going to look at 4 or 5 of these. We'll see how we do. So go ahead, copy this into your notes. We'll talk about how I go about doing it in just a second. So I know it has to be one of the 3. Angle, angle. Well, I'm only given one angle, so that takes that one away. Side, side, side. I'm only given 2 sides, so that takes that one away. So the only way I have possible to do this is by side, angle, side similarity. Okay, I've got 2 sides. I've got the included angle. Angle F and angle T are certainly the included angles. So I've got the included angle part. Now the sides have to be proportional. So I'm going to go 5 over what? 5 over 15, which reduces to 1/3. That's got to equal 3 over 9, which reduces to 1/3. So that works. So they are similar by side angle side. That's step 1. Step 2, we have to write the similarity statement. So triangle, I'm going to start with F. I'm going to go F, E, G is similar to triangle. Which one corresponds to F? Which one? T? F and T go together. Which one goes with E? Here's the F. I go down the short side. Here's T. I go down the short side. It has to be R and S. When they're facing different directions, it gets more difficult. Okay. Just follow short sides when you're doing those. Easy to make mistakes on these. Okay. Questions with that one? Okay, let's look at the second one. Which one are we going to try? Side, 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 side angle, side, or angle, angle? Side, side, side. We're going to try side, 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 see if side, side, side works. Okay, so the largest on the left one is 35. The largest on the right, 25. What's that reduced to? 7 over 5. Okay. Middle length is 28. Middle length is 20. Four goes into 28 7 times. 7/5. Looks good so far. The last one, smallest over smallest. It doesn't look good anymore. I think that's 11 over 8. Are they all the same? Don't think so. So these are not similar. Doesn't matter that these two are the same. All of them have to be the same. Questions with the second one? Let's get number 3. Which one are we thinking? Side, 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 side angle, side, or angle, angle? Do you know any of the sides? No. You don't know any of the sides, so the only choice we have is angle, angle, similarity. So We know this is 53 and this is 42. Can we find that one? 3 angles of a triangle have to add up to 100 and. So if I go 180 minus 53 minus 42, that gives us 85. Okay, so that gives us 85. That gives us 1. We've got this angle and this angle. Are there any other ones that are the same? 42 and 42, right? Vertical angles are congruent. I've got my angle. Don't even care about the other one. So it works. So we've got angle similarity, and that's the easy part. Now we have to write the similarity statement. I'm going to go triangle EBA is similar to triangle. Well, I know the other one that's 85. The other 85 is C. I know the other 42, it's B, and then that leaves D in there to go along with us for the ride. There's our similarity statement. Okay. So vertical angles being congruent, the sum of the interior angles being 180. Alternate interior angles are congruent. Same side interior angles are supplementary. All those things that we've done up till now can come into play in these problems. Okay, let's do this one. We'll do 2 more, and then we'll call it good. Okay, so we got this small little purple one, TSD. It's kind of like the one we did earlier. We've got this bigger triangle sitting there. Kind of draw it sort of like it. FED. We know the D. What's the length from E to D? What's this length right here? 44. 20 plus 24 is 44, so that's 44. 35 plus 30 is 65. So we've got 2 sides and an angle, so we're going to try to prove side, angle, side. We got the angle. It's included. So the longest over the longest, 35 over 65, equals shortest over the shortest. 35 and 65 are both divisible by 5. I think that gives us 7/13. 44 and 24, 8/11. They're not the same. Therefore, they're not similar. We can try it. It's not always going to work. You have to check out the proportionality and make sure the proportions work. Go ahead and give that one a try by yourselves. See if they're similar. And if they are similar, which one? And then write the similarity statement. Interior angles of a triangle have to add up to 180. That makes that angle sitting there 29. It makes that angle there sitting 56. The only angles I have are the same, are the 90-degree ones. The rest of them aren't. So we've got one angle. We don't have two. We don't have any sides. So only one conclusion can be made. They're not similar to each other. Two angles have to be the same. So this is a start. You're going to get some more examples today of different types of problems for these. You're going to get a worksheet today. Now, this worksheet is going to be worked on for the rest of the, 10 minutes that you're in here now still. And tomorrow. There's another assignment sitting in tomorrow's folder, but that one we're not even going to do. Okay, this took a lot longer than I thought it was going to take. The stuff's hard. So we'll finish it up, do a couple more examples tomorrow, but a vast majority of tomorrow will be work time, okay? I know I didn't collect your phones today. I don't want to see them.